Hey, this is Mr. Janes, and today we're going to be talking about right triangle trigonometry. There's a lot of definitions to go over, so the first couple minutes of this video are going to be mostly definitions. After those first couple minutes, we'll show you how to use the definitions, and then finally we'll do some math involving some trigonometry. So to start, we need to know what a trigonometric ratio is. Trigonometric ratio. What it is it's a fraction or ratio. It's a fraction or ratio that compares two sides of a right triangle. Okay, it's a fraction or ratio that compares two sides of a right triangle. For example, if you look down at your notes, you've got this triangle in the middle that has sides 5, 13, and 12. So one trigonometric ratio could be 5 over 13. It's a ratio or a fraction that compares two sides. We also need to know what this symbol is. This symbol is the Greek letter theta, T-H-E-T-A, theta. And theta we're going to use like a variable, kind of like we would use for x, but theta is going to be strictly for angles. So instead of putting an x there as a variable, we'll put theta. The next thing we need to know is what we call each of these sides. The longest side of any right triangle across from the right angle is called the hypotenuse. Okay. But what about the other two sides? Well, the side that is next to our angle theta is going to be called the adjacent side, A-D-J-A-C-E-N-T, because adjacent means next to. And the side that is across from our angle theta is going to be called the opposite side, O-P-P-O-S-I-T-E, the opposite side, right there. Okay. Now, we know what to call the sides. Now we're going to go ahead and learn the three basic trigonometric functions. Okay. Here they are. And I'll put the definitions first and explain them afterwards. Sine, it's abbreviated S-I-N, and sine of that angle theta is going to be the ratio of the opposite side over the hypotenuse. Cosine is abbreviated COS, and cosine of that angle is going to be the ratio of the adjacent side over the length of the hypotenuse. Tangent is abbreviated TAN, and tangent of that angle theta is going to be equal to the ratio of the opposite side, okay, the opposite side over the adjacent side. The opposite side over the adjacent side. All right. Now, those definitions are going to be very, very important to remember. Okay. So, is there an easier way to remember those? Well, there is, and it's with this acronym. So, TOA. What does that stand for? Well, SO stands for sine is opposite over hypotenuse, just like above. Ka means that cosine is adjacent over hypotenuse. And TOA means that tangent is opposite over adjacent. SOHCAHTOA. It'll be very important to write that down on the top of any papers, any tests or quizzes you use trigonometry on, because SOHCAHTOA will be a good mnemonic device to help you remember these definitions right here. Okay. So, moving on. Let's apply SOHCAHTOA to this triangle right here. The first thing we should do before we use trigonometry is label all of the sides. So, this 13 will be our hypotenuse. It's the longest side across from the right angle. This 12 will be the adjacent side next to that angle theta there. So that's going to be the adjacent side. And this 5 will be the opposite side across from the angle theta. So I'll put an O there. So H for hypotenuse, A for adjacent, O for opposite. Now, let's try and write these trigonometric ratios out. Sine of theta. What is sine? Well, let's go back to the top. Sine is opposite over hypotenuse. My opposite side is 5. My hypotenuse is 13. So the sine will be 5 over 13. What about cosine? Well, cosine is adjacent over hypotenuse. My adjacent side is 12, my hypotenuse is 13, so cosine of theta will be 12 over 13. What about tangent? Well, tangent is opposite over adjacent. My opposite side is 5, my adjacent side is 12, so this ratio will be 5 over 12. Now, what if I use a different angle for theta? What if instead of using this angle, we chose this angle up here? Okay, instead of theta, let me call it beta. Looks like that. Okay. What if you use that angle instead? Well, it would change our answers because our adjacent angle and our opposite angle would be different. 13 will still be the hypotenuse, the longest side across the right angle, but now 5 is the adjacent side because it's next to beta, and 12 is the opposite side since it's across from the angle we're looking at, opposite. So now, let's try and figure out what sine of beta is, what cosine of beta will be, and what tangent of beta will be. If you're feeling confident, pause the video here and try and figure out what those will be. Alright, here they are. Sine of beta will be, again, our opposite over hypotenuse, so it'll be 12 over 13. Cosine of beta will be adjacent over hypotenuse, so it'll be 5 over 13. And tangent of beta will be opposite over adjacent, or 12 over 5. At this point, you should be able to do this classwork worksheet right here. Try and fill in the answers, and the answer key will be online. Now starts the second part of this video. Up until now, we've been learning about definitions and learning how to use definitions, but we haven't actually done any real math or any real algebra. In a second, we're going to start that. Before we do, though, we have to know how to use our graphing calculator to calculate sine, cosine, and tangent of various angles. The most important thing to know about the calculator is that there are two different ways to measure angles. One is degrees that we've used before, the other is radians. We need to make sure that our graphing calculator is in degree mode and not in radian mode. So first grab a graphing calculator and I'll show you how to make sure your calculator is in degree mode and not radians. So here's my graphing calculator. You can see right here these buttons, sine, cosine, and tangent, and those are the three main buttons we're going to be using when we do trigonometry. For now, click sine and type in sine of 30 and hit enter. You're going to get this number, negative 0.988, and so on. And that's not wrong. However, that's not the correct answer if we were using degrees. That's the answer we would use if we were using radians, and we don't want to use radians, right? We're used to degrees here. So here's what you need to do. Click mode right here, mode. Scroll down until you see radians and degrees. Go over to degree and click enter. Now degree is highlighted. The calculator is now in degree mode, which is good. We work in degrees. So click second, quit to get back to your home screen. And try that again. Sine of 30. Hit enter. 0.5. That's the answer we should be getting if we're using degrees. And in geometry, we're going to be using degrees. At this point, try finishing the first page of your notes by finding cosine of 85 and tangent of 15. Pause the video here and unpause it when you have those answers. Alright, here are the answers. Sine of 30 is 0.5. Cosine of 85 is 0.087. And tangent of 15 is 0.268 if you round to 3 decimal places. And here are those answers on your note sheet. At this point, we're going to flip to the back side of the note sheet and start working with some algebraic problems. Trigonometric ratios can be used to find the length of a side of a right triangle if you know one side and one angle. In this problem, we're going to round our answers to the nearest tenth. So, just like every other trigonometry problem, we should always start by writing out our acronym. SOHCAHTOA. There it is, SOHCAHTOA. Okay. And by labeling the sides of our right triangle. Okay. Here's the angle we're working with today, 35. So our adjacent side will be 12. Our opposite side will be x. Our hypotenuse will be, well, the hypotenuse. We look at this triangle and say, okay, we want to try and solve for x. So we need to write an equation. And we're going to end up using one of the three ratios, sine, cosine, or tangent. Now, we have the opposite side, or we won't define the opposite side, we have the adjacent side. We have no information about the hypotenuse. So which of the three ratios do you think we're going to use? Well, we won't use sine because sine has to do with the hypotenuse. We won't use cosine because cosine includes the hypotenuse. We will use tangent because tangent has the opposite side and the adjacent side, which is exactly what we have in this problem. So let's write out the ratio. Tangent of 35 degrees equals opposite, which is x, over 12. Now, let's find what tan of 35 is in our calculator. Alright, looks like tangent of 35 is 0.700. So I'll just fill in 0.700 for tangent equals x over 12. Now we've got to solve for x, and the easiest way to do that is just to put a 1 under that 0.700 and treat this like a cross-multiplying problem. Okay? 0.700 times 12 will give us, let's see, 8.4. And x times 1, well, x times 1 is just x, so 8.4 equals x. And there's our answer. X equals 8.4. So coming back to the original problem, this x is now 8.4. At this point, you should pause the video and try the next three problems. Once you unpause the video, I'll go through the next three problems rather quickly. Good luck! Alright, let's start with the first one. So, we've got a right triangle here, okay? It looks like I've got 10 as my hypotenuse, and here's my angle 22, so x will be my opposite side. So we've got a hypotenuse and opposite side. SOHCAHTOA, sine. We're going to use sine there. So sine of 22 is equal to our opposite over the hypotenuse, which is x over 10. If we use our calculator, we find out that sine of 22 is 0.375 equals x over 10. Put a 1 under the 0.375, and we can cross multiply so that x equals 3.75. That's it. Number 2. We've got an angle here that's 65. X will be my hypotenuse, and 11, it's across from 65, so that'll be my opposite side. And it looks like we're going to use sine again. We have a hypotenuse and an opposite. So sine of 65 degrees equals my opposite, which is 11, over my hypotenuse, which is x. Sine of 65 turns out to be 0.906 equals 11 over x. And again, we'll make this into a cross multiplication problem. This one's going to be a little bit different though, because now I have 0.906x equals 11. So let's get x by itself, so I divide both sides by 0.906, divided by 0.906, okay? And x is going to equal, let's see, 12.1, about 12.1, and that ends that problem. On to number 3. In this case, I've got this 49 right here, I've got the hypotenuse is 15, and this x is right next to that 49 degree angle, so that's going to be my adjacent side. I have a hypotenuse and an adjacent side, SOHCAHTOA, SOHCAH. Okay, we're going to use cosine here. So cosine of 49 is equal to adjacent, which is x over the hypotenuse 15. Okay, turns out that cosine of 49 is 0.656, so 0.656 equals x over 15. I'll put a 1 under there, and okay, we can cross multiply and find out that x equals 9.84. Good. So you should now have enough information to try right triangle trig homework, part 1. Just part 1. We'll need some more notes for part 2, which we will do in the next video or next class. Take care.